We are solving log equations. The log equations we solved yesterday, did you feel like those were fairly easy? No response. Maybe they were fairly easy. These may be a step up in difficulty. We have already talked about how to change an exponential function into a log function and the connection between an exponential function and a log function. So we have not quite done problems like this. How do we evaluate these expressions? You see where problem number 1 is on your note paper. Evaluate these expressions. And so, to do that, we're going to think about it in log form. What's the base here? 2 raised to some power is going to be equal to 8. Can we figure out what that power is? 2 raised to some power is 8. Would it be helpful if I had that chart up there that I put up there before? Would that help you figure it out? Well, I'm not putting it back up there. But I will show you how to make your own chart. So please get out your calculator. What was the base we were dealing with? Base 2. So over here in my calculator, I'm going to put 2 raised to the x power. And then I am going to push second graph, and that gives me a table. So this is the powers, and so 2 raised to the third power is equal to 8. So do you see it's the same thing, the same kind of chart, only the chart's in the calculator instead of on the board, so you can make your own chart. So what is the answer here? This is 3, because 2 raised to the third power is 8. What's my base here? 7 raised to some power is 1 over 49. So over here in my calculator, I need a base 7. And so I see, well, you probably already knew. You didn't probably need a calculator to know that 7 raised to the second power is 49, but that doesn't say 49. It says 1 over 49. How can you get a 1 over 49? 7 squared would be 49. If I put a negative sign in front of it, it makes a reciprocal. 1 over 49 is the reciprocal of 49. Oh, this one's going to be a hard one. 1/3 raised to some power is equal to 27. 1/3 is the reciprocal of 3. This 3 could be written 3 to the negative 1, that's equal to the 1/3. A negative 1 power is a reciprocal. This needs to be an x. 27 is 3 to some power. What power would I need up here so that this would be equal to the 27? Well, if you don't know, we go back to our calculator and we look at our calculator. Here's the power. If the power is 3, that's equal to 27. So, can we solve this? I'm running out of room here. Negative x equals 3. So, x is equal to negative 3. That one's pretty hard. Because to get that, you need a reciprocal of a reciprocal. Raise your hand if you need another second to copy that down. I need to change this to exponential form. And so what's the base? I don't know the exponent, that's why I'm calling it x, and that equals to 2. Is that even possible? Can I raise 4 to a power and come up with 2? Yes, I can. But in order to do that, I need to have the same base. Isn't 4 equal to 2 squared? 4 is equal to 2 squared, and then I have the x, and that's equal to 2 to the first power. When you have a power raised to a power, you multiply them together. I'm going to have to go up here to the top of the board to finish this out. And so then that means that 2x has to equal 1. Is it possible to solve that? I'm going to divide by 2. So x equals 1/2. Check it out to make sure. Is 4 raised to the 1/2 power, is that equal to 2? 4 raised to the 1/2 power, oops, that wasn't a 1/2 power, equals to 2. Okay, and now these were not actually equations because it didn't have an equal sign. We were evaluating these logs. Now we're going to solve some log equations. We're going to solve these log equations by changing them to exponential form. That is what we started with, and that was the first lesson in this unit, and most of you did very well on it. This is going to be the base, this is the exponent, and it's equal to x. This is the base, this is the exponent, and it's equal to x. How can you solve that? Can you put 9 raised to the 2/3 power in your calculator and see what it's equal to? When you do that, make sure you put parentheses around the 3/2. What is 9 raised to the 3/2 power? 27 equals x. That one was pretty easy because we got to use our calculator. And so on this one, we're going to change it to exponential form. 3 raised to some power is equal to 81. This is a little bit more difficult because we're not given the power. And so that means we have to figure out what that exponent was. And so our calculator can help us out. We're base 3. What power am I going to need so that it would be equal to 81? So y is going to equal to 4 because 3 raised to the 4th power is equal to 81. Do you have any questions? I see no questions. Uh-oh. There's no base on problem number 7. If the base is not written, the base is 10. If there is no base written, the base is 10. So 10 raised to the 3rd power is equal to x. What is 10 raised to the 3rd power? On the next one, what is that going to be in exponential form? What's the base? Y raised to the negative 3 power is equal to 27. What is that going to be? Some kind of 3, right? It's going to have to be some kind of 3. So is 3 to the negative 3 power, is that equal to 27? What's that equal to? 3 raised to the negative 3 power. What's that equal to? Is it equal to 27? What's it equal to? If you're using your calculator and you have a decimal number, remember to push math enter to change it into a fraction. So what's that equal to? 1 over 27. So that's the reciprocal. I'm getting close, but I'm not quite there. And so try this one. If 3 raised to the negative 3rd power gave me the reciprocal, what if I take the reciprocal of 3 and raise it to the negative 1/3 power? Does that give me 27? So y is equal to the 1/3. The 1/3 is what I need to take. This is like a reciprocal of a reciprocal to give us the 27. Now, in our problems that we had yesterday, we had a log equal to a log. These problems, though, don't have a log on both sides of the equation. How many logs do I have in this equation? And so I need to isolate this log, and then I'm going to change it to exponential form. How can I isolate that log? Maybe I could try this. Before you put it in exponential form, you have to isolate the log. On the previous examples, the log was already isolated. Now can you change it to exponential form? What is going to be the base? 3 raised to the 4th power is equal to x. What is 3 raised to the 4th power? If the equation only has one log, you need to isolate that one log by itself. You need to isolate the log, subtract the 16 first, and then divide by the 2 so that this log will be isolated. Log 2 of x equals 7. Now what? Change to exponential form. If I change to exponential form, what's going to be the base? 2, what's going to be the power? 7 equals x. What is 2 to the 7th power? What? 128. Can I check it with my calculator? The answer to that is no. If you will see a log button on your calculator, but if you push that log button on your calculator, is there a base written? So if the base is not written, the base is 10. And so the calculator does base 10, was my problem base 10. And so some people try to put that in the calculator by just sticking a 2 in there and calling it a base, but that's not how the calculator is programmed. And